Hello student. So today we are going to discuss very important chapters is nothing but redox reactions. And in redox reactions, first you need to know few things. What is called as a reductions reactions, what is called as a oxidations reactions, basically in terms of a definitions of electron, and what is oxidizing agent and what is reducing agent. So let us focus on that. So redox reactions. In redox reactions, what you need to know first, what is called as a reductions reactions, what is called as a reductions reactions. Already you know, my dear student, the loss of oxygen is nothing but a reductions, gain of hydrogen is nothing but a the reductions, or in terms of electron, the gain of electron is nothing but a reductions. In terms of a hydrogen and oxygen, you know very well, addition of hydrogen is a reductions, gain of hydrogen is a reductions, loss of hydrogen is a oxidations, or removal of hydrogen is a oxidations. In terms of a oxygen, the gain of oxygen is a oxidations, loss of oxygen is a reductions. But in terms of a electronic definitions, gain of electron is a reductions. What is oxidations, my dear student? Oxidations is nothing but a what? Loss of electron or the removal of electron. Loss of electron is nothing but a oxidations. What is oxidizing power? This 4 point you have to remember always. Oxidizing power. Oxidizing power is nothing but a what? Always you remember, suppose I am telling the oxidizing power of this chalk piece. So then you have to understand this chalk piece will oxidize the other species, but itself will go for a reduction. So that is why oxidizing power means ability to snatching the electron, ability to snatching the electron, snatching the electron. Always this 4 point you remember. And then reducing power means what, my dear? Reducing power means or reducing agent if they ask you, then you have to remember ability to supply the electron, ability to supply the electron, to supply the electron. So these 4 point you have to remember. So that means, suppose I am telling the reducing power of this chalk piece, that means this chalk piece will undergo the oxidations and it will reduce the other species. When it will go undergo oxidations, it has to lose the electron. That means it is supply the electron to help the reduce the other species. So that is what you have to understand this 4 point. The reduction is a gain of electron and then oxidation is a loss of electron. Oxidizing power means ability to snatching the electron. Reducing power means ability to supply the electron. This 4 point if you understand nicely, so whatever way they will ask the questions, you will do effortlessly. These things also will be correlated with the electrochemistry. So that is why this chapter is very, very important chapters. So that is why first you understand these things. Then we need to tell about this. Suppose if you look at reductions means what? I am writing the reductions, oxidations plus oxidations. So now by combinations of these two, you look at, when we are combining these two, then we are getting which thing? We are getting redox. So that means the reaction where the simultaneous reduction and oxidation is taking place, that is called as a redox reaction. By combinations of reduction and oxidations, we used to proceed, that reaction is called as a redox reactions. So now once you understand this redox reaction, then you need to know oxidation's number or the oxidation state of any element of atom in a different compound in their native state. For that you need to know certain rule. So now we are focusing how to find out the oxidation state of any element of atom in a compound or in a native state. We need to know the certain rule. So let us focus on that rule. So now if you look at that things, then I am telling you these things, you will understand very nicely that one. Suppose I am telling you is nothing but a, what I am telling you? I am telling you nothing but a, you look at, suppose I am telling you these things. If you look at that, I am telling you group 1 element. Group 1 already we completed S block element, P block element. So then group 1 element, what are the element? Lithium, sodium, potassium, rubidium, cesium, francium. And now the lithium electronic valence electronic configurations, helium code 1s, 2s, 1s2, 2s1, atomic number is 3. Sodium, neon code 3s1. So neon code 3s1. Potassium, argon code 4s1. Rubidium, krypton code 5s1. And then cesium, xenon code 6s1. So this is the valence electron is nothing but the highest number of n corresponding orbital containing total electron is called as a valence electron. All cases the valence electron is 1. Now to attain the inert gas configurations, how many electron need to lose or how many electron need to add is nothing but a oxidation state of that element of atom. So now lithium or sodium or potassium or rubidium or cesium, group 1 element, if they lose this electron, if they lost that electron, then the lithium will be like what? Helium, like inert gas configurations. So that is why the oxidation state OS or oxidation's number for the group 1 element will be nothing but what? +1. When the 1 electron is losing, the protonic charge will dominate over the electronic charge. So that is why you have to understand the oxidation state of group 1 element will be nothing but how much, my dear? Always +1. Got the point, my dear student? So now for the group 2 element, likewise for the group 2 element, if you look at, they need to lose the 2 electron to attain the inert gas configurations. So that is why the common oxidation state for the group 2 element or oxidation's number will be nothing but how much, my dear? +2. For the group 2 element means what, my dear? Beryllium, magnesium, calcium, strontium, barium, radium. So they need to lose the 2 electron to attain the inert gas configurations. Whereas come for the group 13. Group 13 element means what? Boron, aluminium, gallium, indium, thallium. If you see in their valence electron, there are 3 valence electron is there. To attain the inert gas configurations, so during the p block element I discuss these things: boron, aluminium, gallium, indium, thallium. Thallium I am writing xenon code, and then 5d10, 4f14, 6s2, and then 6p1. So now general oxidation state of group 13 element is nothing but a +3. They need to lose that 3 electron to attain the inert gas configuration. But the thallium during the p block element already I discussed, the thallium stable oxidation state is nothing but a +1. Why? Because of inert paired effect, because of fulfilled d and f orbital electron is present, because of the poor shielding of the d and f orbital electron, this 6s2 electron will not participate in bonding. That phenomena is called as the inert paired effect. Because of the inert paired effect, only 1 electron will participate in bonding and they need to lose. That is why the stable oxidation state of thallium will be +1. Whereas group 13 element general oxidation state will be nothing but how much? +3. Got my point, my dear student? And then group 14 element. Group 14, what are the element is there, my dear? Carbon, silicon, germanium, tin and lead. So now here if you look at any one, for that example we are writing for the carbon, valence electron how many is there? 4. So that means all element valence electron will be 4. So that is why they can attain the inert gas configurations either losing the 4 electron or gaining the 4 electron. If they gain the 4 electron, then also in the valence shell there will be 8 electron. Already we know if anything has in their valence shell 2, 8, 18 electron, that will be like inert gas configurations. That is nothing but give you the extra stability. So that is why if they lose 4 electron, they will be like a helium. If they accept another 4 electron, they will be like a neon. So that is why, so the general oxidation state for the group 14 element oxidation state will vary from +4 to how much? -4. In that range it will be vary. If you take the example later, I will come example, you will understand clearly. So now group 15 element. For that group 15 element is nothing but a nitrogen, phosphorus, arsenic, antimony, bismuth. There are 5 valence electron will be there. If you write down the electronic configurations, you will see. So that means they can lose the 5 electron or they can accept the 3 electron to attain the inert gas configuration. That means in a valence cell there will be 8 or there will be 2 or there will be 18 electron. So that is why they can lose 5 electron. That means the oxidation state will be plus 5. If they accept 3 electron, oxidation state will be minus 3. So that is why plus 5, when the 5 electron is losing, the 5 protonic charge will be dominant over the electronic charge. 5 extra proton will be there rather than the electron. That is why plus 5. So that is why the range of oxidation state for the group 15 element will vary from where? Plus 5 to minus 3. So that is what you have to understand. And now group 16 element, same valence electron is 6. They need to lose 6 electron or they need to add 2 electron to attain the inert gas configurations. So oxidation state will vary plus 6 to minus 2. So that is what you have to understand. And then group 18 element is group 17 element. Valence electron is 7 like fluorine, chlorine, bromine, iodine, astadine. Either they can lose 7 electron or they can accept 1 electron to attain the inert gas configuration. That is why here the general oxidation state will vary from where? Plus 7 to minus 1. This is the group 17, and group 18 already is called as a 0 group. Among the group 18 only xenon used to form the compound like XeF2, XeF4, XeO2F2, XeOF4, like that compound used to form. So these are the basic understanding first you need to know. I hope you understand these things. Next, what you need to know? Another way we can define the oxidation state. So what is that oxidation state? So oxidation state can be defined in another way. So that is what, once you understand these things, so then you look at the oxidation state can be defined in another way. What is that way? The oxidation state, they are telling like that. OS means oxidation state or oxidation number, whatever you call it. So oxidation number, it is a imaginary state, it is a imaginary number, it is a imaginary number developed imaginary number developed when bonded electron given to the most electronegative atom in a bond, most electronegative atom in a bond, most electronegative atom in a bond. So now that is why that is called as a oxidation state. What is that? It is developed, it is an imaginary number developed when bonded electron given to the most electronegative atom in a bond. That is nothing but an oxidation state. So now if I give one example, suppose methane, you look at this methane. So now in the methane, carbon is more electronegative element than hydrogen. Everybody knows, my dear student. So now for this bond, carbon will be what? Plus 1, carbon will be minus 1, and then hydrogen will be plus 1 because I am giving bonded electron pair to the more electronegative atom. For this bond, another minus 1 for carbon, plus 1 for hydrogen. For this bond, hydrogen will be plus 1, carbon will be minus 1. For this bond, hydrogen will be plus 1, carbon will be minus 1. So then overall oxidation state of carbon will be how much, my dear? Minus 1, minus 1, minus 1, minus 1. So then the oxidation state of carbon in methane will be nothing but how much? Is nothing but a minus 4. You got the point, my dear student? So now if any hydrogen, oxidation state how much? Plus 1 in the methane. Likewise, if you come for the carbon dioxide, like this scenario. So if you look at, for one bond, carbon will be how much? Plus 1, because oxygen is more electronegative element. Another bond is there, oxygen will be another minus 1, and then carbon will be another plus 1. For this side you can, for one bond, carbon will be nothing but another plus 1, oxygen will be minus 1. For this bond, oxygen will be minus 1, carbon will be plus 1. So that is why overall oxidation state of carbon will be how much, my dear? Is nothing but a plus 4, whereas each oxygen atom will be nothing but a minus 2. This is nothing but a minus 2. Overall will be molecule will be neutral. So that is what you have to understand. I write down this statement. It is an imaginary charge developed when the bonded electron pair, if you give to the most electronegative atom, that is nothing but a oxidation state. Actual, in originality, their existence is not there. You got the point, my dear student? Now that is what you look at. Carbon can be minus 4, carbon can be +4. That is what when I discussed for the group 14 element, the range of oxidation state vary from what? +4 to -4. That means they can lose the 4 electron, they can accept the 4 electron to attain the inert gas configuration. That is why the range of oxidation state will be +4 to -4. Got the point, my dear student? So now there are certain rule. Again, the next rule we can explain the hydrogen. The hydrogen generally will be, hydrogen oxidation state generally will be nothing but a +1 with non-metal. With non-metal hydrogen will be what? +1. Whereas with metal hydrogen will be -1 with metal, metallic hydride. You know, like sodium hydride. Sodium group 1 element +1, hydrogen will be how much? -1. So that is why in a metallic hydride, hydrogen will be -1, whereas with the non-metal like carbon, methane, hydrogen is how much? +1. This is the rule you have to understand. Like oxide, oxygen in oxide form, oxygen oxidation state will be each oxygen atom how much? -2. Like that carbon dioxide, you look at -2. Whereas the oxygen atom will be in the peroxide form. When it will be there in a peroxide form, oxygen atom oxidation state will be how much? Each oxygen atom? -1. Whereas oxygen atom in superoxide form, the oxidation state will be nothing but a -1/2. If I give example, magnesium oxide, here magnesium is +2, oxygen is -2. Magnesium is a group 2 element, oxidation number or oxidation state is +2, already I discussed. So oxygen is -2. Like peroxide, hydrogen peroxide, this is called as a peroxy linkage. Hydrogen +1, +1, -1, -1, overall molecule neutral. So peroxide is each oxygen atom is -1. Superoxide like KO2, potassium is +1, each oxygen atom -1/2 into 2, that is nothing but a -1, -1 and +1, overall neutral molecule. So that is why oxygen atom in oxide form -2, oxygen atom in peroxide form -1, oxygen atom in superoxide form -1/2. Got the point, my dear student? So then next rule you have to remember, hydride peroxide, for the anything is there is nothing but a which way? Suppose they are giving the oxidation state of an ion. So charge on the ion is nothing but oxidation state. So charge on the ion, suppose I want to find out the oxidation state of the charge on the ion of this radical. Suppose I am telling Cl minus, oxidation state -1. Suppose I am telling SO4 2-, oxidation state of ion is nothing but how much? 2-. But how to find out the oxidation state? There is one method is there, you know very well, that is nothing but suppose I am telling overall charge is 2-, they are telling find out the oxidation state of sulfur. I am telling oxidation state of sulfur is X. So then how many sulfur is there? Only one. X plus, each oxygen atom will be -2. So that is why in oxide form -2, superoxide -1/2 and peroxide -1. So that is why X plus 4 into -2, overall charge is there how much? -2 for this one. So then X minus 8 will be equals to -2. So X -2 plus 8. So X will be equals to how much? +6. That is why oxidation state of sulfur in this SO4 2- will be nothing but how much? +6, my dear. So this way we used to find out. But this is time consuming. Once you will be expert, by seeing itself you will count like this. 4 into -2 -8. So obviously it will be +6, then only overall -2. Like that you have to proceed. You got the point? This is done by the student who are learning first time, they will do like this way. Got the point? So now for the transition element used to show the variable oxidation state. Transition element used to show the variable oxidation state. And then because of the partially filled d orbital is there, variable oxidation state. So now generally the stable oxidation state for this transition element +2 or some cases +3. Now you look at generally scandium, titanium used to show +2 oxidation state, whereas chromium, cobalt, they used to show +2 or +3 oxidation state. Just roughly you remember these things. Then the manganese used to show +2 to +7 oxidation state. Manganese used to show +2 to +7 oxidation state, whereas iron used to show +2 or +3 oxidation state, but Brown ring test complex, Brown ring test oxidation state of iron will be nothing but how much, my dear? +1. In the Brown ring complex, oxidation state of iron will be what? +1. You have to remember these things. Got the point, my dear? And now, moreover, if you come for the nickel used to show +2 or +4 oxidation state, and then copper used to show +1 or +2 oxidation state, and then zinc used to show the +2 oxidation state. So these are the basic thing you have to remember. And now once you understand these things, and the lower oxidation state is called as a as, higher oxidation state is called as a ic. So these are the basic things you need to know, and then we are proceeding giving some compound. You have to find out what is the oxidation state of any element, or any element is there in a native form, like chlorine. Oxidation state will be each chlorine atom 0. Like I am writing hydrogen, oxidation state will be 0. Oxygen, that means the substance, when any substance found in a elemental form, the oxidation state will be nothing but how much? 0. So these are the basic thing you have to understand. So once you understand these things, then I am going to give certain example regarding how to find out the oxidation state in a different element, moreover some exceptional cases. So let us focus over there. So now once you understand these things, then we are proceeding towards that. Suppose if you look at, I am writing over here, if you look at, they will give you, first I am giving you potassium permanganate. What is the oxidation state of manganese over here? Potassium permanganate. If you don't know, you can find in that methodical way. So let the oxidation state of manganese is X. Overall molecule is a neutral molecule. How many oxygen, my dear? 4 into -2. Oxide form, generally oxygen in the oxide form, rather than when they will be there, peroxide in -1, superoxide is -half, and then potassium is there +1, each one potassium, plus oxidation state of manganese is X. Overall charge will be, this is a neutral molecule, is nothing but a 0. So then we can get -8 plus 7 plus X will be equals to 0, -7 plus X will be equals to 0. So X will be equals to nothing but how much? +7. So immediately you will get the oxidation state of manganese in which state? +7 oxidation state. Got, my student, my dear student? And then they give you potassium dichromate. Now I am doing it very fast. So that means immediately you can calculate from the mouth itself. 7 into -2, -14. So then 2 into potassium +1 is nothing but a +2. So +2 and -14, -12. Obviously each chromium atom should be nothing but a +6. Then only overall molecule will be 0. So that is why the oxidation state of each chromium atom will be nothing but how much? +6 oxidation state. You have to calculate by mouth itself. Got the point? Who are learning first, they will do like this. You can do like this, but in a NEET exam, time is a factor. 180 minutes, 180 questions. One question maximum 1 minute. So that is what you have to save the time for this type of calculation you will do by mouth itself. Got the point, my dear student? So now, then I am giving you some exceptional cases. What is the oxidation state of sulfur in H2H2O8? So H2H2O8 is called as a per-disulfuric acid or Marshall acid. So it's a, now immediately if you calculate 8 into -2, -16, and 2 into hydrogen +1 is nothing but a +2, +2 minus 16 is nothing but a -14. So each sulfur will be +7. But the sulfur +7 is not possible. Group 16 element maximum oxidation state will vary -2 to +6. Already I explained group 16 element. But how possible it will be +7? So that means the oxidation state of sulfur here will +7 will be not possible if you calculate in normal way. Then here something is happening. What is happening, my dear? We need to know the structure. So here the structure will be like this. All oxygen will not be there in a peroxide oxide form. Some oxygen will be there in a peroxide form. This is the structure over here. Now you look at around this sulfur. This oxygen -2, out of -2, 1 will be neutralized by hydrogen. So overall will be there -1, -2, -2. This is a peroxide, -1, -1, -2, -2, -1. So overall around the sulfur to make a neutral molecule, sulfur has to be what? +6. This sulfur has to be what? plus 6. So that is why oxidation state of each sulfur atom is nothing but how much, my dear? Plus 6. Clear? So this way you have to proceed. Got my point, my dear? So now another very interesting compound is there. So we need to know H2SO5, that is called as a Carros acid. H2SO5. H2SO5 is called as a Carros acid. This is Marshall acid or pardisulfuric acid. Marshall acid or pardisulfuric acid. This is called as a Carros acid. Carros acid. What is the oxidation state of sulfur over here? Here also tricks is there, you need to know the structure. The structure will be like this, my dear. These things, this, and then this, and then this. This is a peroxide which will be balanced by this. And now this is plus 1, minus 2. So effectively minus 1, minus 2, minus 2, minus 1. Overall plus 6 oxidation state will be there over here itself. Got the point, my dear student? So this way you have to proceed. Now another interesting compound is there. What is that? Another interesting compound is there. If I focus that one, some exceptional compound like the CrO5. What is the oxidation state of chromium? CrO5 and CrO6. The chromium general oxidation state will be nothing but a plus 2, plus 3. But variable is also possible, already we know. So now here you need to know the structure. The CrO5 structure will be like this. So CrO5 structure will be like this. So this is a peroxide minus 1, minus 1, minus 1, oxide minus 2. So overall chromium will be what? Plus 6. So that means chromium can also show up to plus 6. But generally plus 2, plus 3 is available. But more than that also possible. As a transitions element, they used to show the variable oxidation state. Got my point? So now if you look at CrO6, CrO6 all will be there in a peroxide form. The structure will be like this. CrO5 structure will be like this. Minus 1, minus 1, minus 1, minus 1, minus 1, minus 1, plus 6. So these will be nothing but this structure. Got the point, my dear student? Then another very interesting compound is there, K3CrO8. K3CrO8, if you look at the structure, K3CrO8. What is the oxidation state of chromium over here? This is you need to know the structure. Here the structure will be like this, my dear. This structure will be like this. You need to know structure. This is all here peroxide form. These 3 minus will be taken by potassium, which will be balanced by potassium. So then around the chromium minus 1, minus 1, minus 1, minus 1. Chromium will be plus 5. Then only overall molecule will be neutral molecule. All oxygen is there in a peroxide form. Got the point, my dear student? And now then very important, C3O2. This is called as a carbon suboxide. What is the oxidation state of each carbon? Suppose if you look at the structure will be like this. That C3O2 structure will be like this. C3O2 structure is this. For this oxygen minus 2, carbon will be what? Plus 2. For this oxygen minus 2, carbon will be plus 2. This carbon is 0. If they told you the 2 terminal carbon plus 2, middle one is 0. But the average oxidation state plus 4, which will be shared by the 3 carbon atom. So average oxidation state of each carbon atom will be 4 by 3. Total is 4 divided by 3 carbon, 4 by 3. Got the point, my dear student? And another very important compound, 2 times they ask these questions, Br3O8. Br3O8, structure you need to know. Br3O8, what is the oxidation state, average oxidation state of bromine as well as each bromine? Structure you have to remember. This is Br3O8 structure will be like this. This is a Br3O8 structure will be this. Minus 2, minus 2, minus 2. Bromine plus 6, minus 2, minus 2. Middle bromine plus 4, minus 2, minus 2, minus 2. Terminal 2 terminal bromine will be plus 6. Middle bromine will be plus 4. If they told average oxidation state of bromine, average oxidation state of bromine will be equals to how much? Total oxidation state is 16. 6 plus 6, 12 plus 4, 16, which will be shared by how many bromine? 3, 16 by 3. Got the point? So this type of questions they used to ask. Another one I want to discuss, but before that I am finishing this class, and the next class I am going to discuss is nothing but a balancing of a redox reactions, and before that few things I will discuss some exceptional category. and then we will start the balancing of a redox reactions. Thank you very much, student. Thank you all.